Hydrologic functions in GIS allow us to use various hydrology layers or to even create hydrology layers in order to better understand how water moves over the surface of the land. So some of the components in a typical hydrologic type of analysis might be a watershed. That would be all of the surface area drained by various streams. It could be the streams themselves, other water bodies, or it could also include monitoring points where the water is actually measured. So for example, this would be one hydrologic unit or watershed, and we can see that all of the water that falls somewhere within this boundary would eventually, assuming it didn't filter into the groundwater, would eventually move across the land and contribute to this river that's flowing across this area here. So how does it work? It's based on a digital elevation model, and it makes one assumption, that water flows downhill, which we know that it does. So basically, the first thing it does is for each of the different grid cells within the digital elevation model, it calculates a flow direction. And the flow direction is going to be the steepest direction based on surrounding grid cells that the water would flow. So water from this grid cell could flow over to this grid cell, or down to this grid cell, or over to this one, or over to this one. But we can see in this case here, this water flows down into this grid cell. Then we can sort of put together a network showing how all of these connections take place. So this grid cell would flow into this grid cell would flow into this grid cell, and this grid cell would flow into this grid cell. We can represent that as a flow accumulation. So this grid cell here has accumulated flow from 3 other grid cells. So we could see that's a flow accumulation of 3. As we get into bigger ones here, we can see this grid cell is accumulating flow from this grid cell, from 3 plus 1 from this grid cell, from 2 plus 1 from here, and from 2 plus 1 here, for a total of 11 here. So we can see how flow is accumulating, and just as we would expect, it kind of gets more and more in the steepest downslope direction. And then we can actually convert this from a raster into a vector format if we want to just use some sort of cutoff, like at least a flow accumulation equal to 3, and just connect the center of those grid cells. We can see that a lot of them in this case would not be included because we must be up near the beginning, the highest parts of this watershed. And as we move down further and further, we would expect flow accumulation in the rivers themselves to get higher and higher. In this way, we can actually model where rivers should be, even if we don't have a river coverage. This is an example here in the Scappoose Bay watershed north of Portland, Oregon, and we can see here that the colors vary from light blue to dark blue based on how much flow accumulation has gone on. And this has now been converted into acres instead of grid cells. But we can see in the highest reaches, it's a light blue. As we accumulate, we get into the darker blue, and then the darkest blue as we move down through these areas here. We can also build watersheds out of this by just seeing where flow accumulation is going in different directions into different drainages. And this shows all the hydrologic units or watersheds for the state of Montana. So we can see that all of these various watersheds are out there, and we can use this as sort of a natural irregular grid in order to map other data. For example, this is a map showing showing precipitation across the state of Montana. And what we can do is we can use these hydrologic units or watersheds in order to summarize how much rain falls in each of those watersheds. So we would simply take all the grid cells within watersheds, and then we would summarize it to say how much precipitation, inches per year, fall within each of those watersheds. What we can see here then is kind of an input into the hydrologic system. The rainwater comes into the system, and if we know then how much water flows out of the system by water monitoring stations, and also how much water is evaporating off the ground, which we can do in various ways, then we can understand, for example, how much water from rain is infiltrating into the groundwater throughout this area here. So it kind of becomes a mass balance thing where we know some values and can estimate other values, which can be very useful for environmental assessments.